Let's go live on TikTok and YouTube. All the platforms. TikTok's actually been doing pretty well recently. At least from our tutorials that we put out. It's been really cool to watch. Here, let me get that working. Let me get YouTube Shorts. No, that was not working. One sec. There we go. Cool. All the chat clients should be working now, hopefully. But yeah, I did like a Volumes of Revolution video on TikTok. Oh, I put it on all the platforms. So it's very interesting. It's actually been doing pretty well. So the part 2 I did has 16.7 thousand views on it, which I think is awesome. That's really cool. Whereas when I put it on YouTube, it didn't do as well. So kind of curious to see how different content does on different platforms. This is also why you should always post your platform on everything. Yeah. Oh, it's not terrible, but yeah, only like 2,000 views on YouTube. Yeah, we can do some physics. You can't hear anything, David? Oh no. Maybe someone else in the chat. Can you let me know if you can't hear anything? I think people can definitely hear it on the streams. Maybe Discord's being weird. Mahmood, yes, if we want to do some physics practice, we totally can. So, you as well? Oh, okay, one sec. Let me figure that out then. Because my screen looks green. Here, let me leave the stage. Let me talk back on the stage. Wait, how do I go to the stage? One sec. Okay. I forget how this works. Let me end the stage. Okay, there we go. Alright, can you hear me now, David? Is that working? Yeah, I sound fine on Twitch. Yeah. It's Discord. Discord's being kind of weird sometimes. Let's see. There you go. Let me know, David Magnus. Okay, great. Yeah, we can definitely do some physics practice. So, if you guys want to submit any questions for us to go over, the website right there, actualofficehours.com. That's where you can drop in a little screenshot of something you want to work on. Put your username so I know whose question it is. Oh, now you can hear me? Nice. Yeah, Discord's weird sometimes. But yeah, please just let me know. And then what I'm going to do is I'm going to look through the queue. Do you do organic chemistry? I have a friend that does organic chemistry. So, if he's here in the stream, his name is JC. JC, you here? Is JC here in the stream? You can always submit a question. And even if I can't do it, I can definitely do chemistry. OChem, I took at one point in high school, but as far as tutoring it might be a little tricky. But if I can't answer it, one of our friends will also be able to answer it at least. I know lots of smart people. I've been blessed with that in life. It's OChem too. Uh-oh. We'll try submitting it. You submitted yours in homework help? Okay. Where's the server link? So the same website, actualofficehours.com, that link right there. David, can you put it in the queue? Can you put it in the queue system? Just so it's easier for me to see it there. Because, yeah, we're live on 4 platforms. We're live on Discord, YouTube, Twitch, and TikTok. So this website here is how we take in all of the student questions and we put them in one place so that I can just like kind of work through them. But the server link, so actualofficehours.com, will bring you to this website. And that's where you can drag and drop in your screenshot. And then there's also a link to join the Discord here. Which is, yeah, where other people hang out as well. Is there no Discord? There's a Discord. So if you click here, join our Discord link, you should be able to see it, yeah. Also, why is my chat not working on TikTok? One sec. Always something these days. Always something. That one's okay. This one is not. One sec. Let me delete this. I gotta like put it back sometimes. Boom, boom, boom. There we go. Let's copy that in. And I gotta put in a source. The TikTok streaming client is very buggy. I wish they would just give me, you know, a stream key so I could use OBS. It'd be so nice. There we go. Okay. Yeah, see? Now my chat will work. What's up, Vale? Yeah. Here, let me see. What's up, Foreman? Good to see you, Foreman. Well, there it is. Wait, why is it not showing up, though? One sec. I think I need my height to be 275, I think is the magic number. Yeah, but where is it now? Oh, TikTok. Okay, anyways. What's up, Ethan? How's it going?
Hey, sorry. Yeah, I'm sorry for these late, these like not late, but these random like showing up times. Like I'm not showing up as often then.
No, it's okay. What is I imagine you're really busy at college, right? You have a lot of stuff going on. Oh, nice.
Yeah, it's true. Yeah, sorry. Listen, I mean, I'm trying everything, but the time's not allowing me to even come here. I hate it.
That's okay.
Yeah, how's it been going? Happy New Year's, by the way. I'm just talking to you, so.
Oh yes, Happy New Year. What's up, Greg? Good to see you, dude.
How's the New Year's treating you?
It's been good. It's been good. We've had a lot of people submitting questions and stuff. Things have been growing. I keep putting out more videos. People are giving me OChem questions. What's up? Thank you for the OChem shots. I see it. This is OChem. Synthesize the molecule for benzene. Wow. Okay.
How's that going?
What's up?
I have to tell you, college is not so bad, you know, but
good. College is
I'm
dope.
starting to feel like
I like college.
I'm starting to feel like I feel like this New Year's is not really treating me to the best start at all.
It's okay. Ooh.
Like
why? What's not going the best? I mean, life is a lot of ups and downs for sure.
But like, okay, there's two things really quick. So the first one, which I don't like, is like, you know how they say you're digging yourself into a hole that eventually you will not escape?
Yes. I've definitely dug myself into holes before, for sure.
The thing is, I'm kind of doing that right now because that cheating thing is starting to become a little more frequent than I realized.
Oh no, don't do it.
Surprise, motherfucker.
Yeah, I always say when you cheat, you're just cheating yourself, though. You know, you need to be able to struggle. You don't want crutches for too long.
I know, like seriously, it's just this professor, he doesn't give back questions, and I'm just trying to take screenshots of the questions so that when the exam comes, I just know the answers and I can understand it.
Do you understand how to do the questions? That's the important thing.
Yes, after the test, and then I realized, oh wow, it was just that simple.
Yeah. Greg, just Greg, on the website actualofficehours.com, just click on join our Discord here. You'll be able to join.
Yeah, I mean, I'm not sure if that is considered cheating or not, but the professor literally doesn't even send back questions.
No, it's okay. I don't think that's really cheating. I mean, as long as, yeah. I mean, that's called studying.
Good job.
Knowing how to do questions and get the right answer is studying. That's not cheating. Cheating is if you just look up the answer and you don't know, like, where it came from.
I try my best to understand. It's like I answer first, then I look at the answer, and then I realize, what the flip did I do wrong in this? That's what I did sometimes. I mean, I try to resist, but at the same time, I just want a high score so I can get a 4.0 GPA. I hate my life, you know. I hate my life like this.
It's okay.
But there's another thing.
What's the other thing?
The thing is, like, a person who I used to trust saw me utilizing AI for one of the things, you know.
Okay.
And
I use AI all the time. It's okay to use AI.
I mean, during an assignment or a graded activity, we weren't supposed to use it. So like a quiz then. The thing is, the thing is, he did a video presentation. His group could not answer a question, and he just got completely livid. To the point
Yeah.
that even though I wasn't directly involved, he's going to tell the professor what happened during that. And I mean, while the professor doesn't really know necessarily, it's just I'm not friends with him anymore, and
What's up, buddy?
I just lost a friend. I just lost a friend, basically.
It's okay. I mean, you lose friends and you gain friends all throughout life. That's part of living.
I don't gain much friends. That's
and maybe they'll come back to being your friend. You know, you can also forgive friends for, like, you know,
forgive
slighting
friends
you.
after what he tried doing. He's trying to betray me.
Okay, but maybe he made a mistake. Don't be so
He's
fast to
not-
cut people off. I don't cut people off very quickly unless, like, they really do something bad to me.
Yeah, to be honest, I don't have him blocked or anything, but I'm just not talking to him right now.
Okay. Sometimes you just need a little bit of space.
Oh, but you know, I have to tell you, classes other than the cheating have been going really well. I could post up my grades right now. They are not so bad.
Go post your grades. Mahmood, I think I did, Mahmood. Yeah. Is this your... Yes, I got the physics question, Mahmood. I did. Here, let me try to work on this question from David. This is a statics question. Looks like statics. Yeah, it's an engineering question.
What is statics in engineering? Because when I hear static, I just like when one thing stays the same.
Yeah, exactly. Static is when something like stays still, right? Yeah. So this is an example of a statics question, which you're saying a come along. I don't know what a come along is. Oh, nice grades there, Ethan. Nice.
Good job.
Almost all A's. Just English.
You see how I have?
Hey, you're doing well.
Yeah, I have to tell you, for math 109, which is pre-calculus, is like somewhat easy, but I am starting to get the struggle in. The struggle is real now.
The struggle is real.
Like
it happens.
Like, if you don't, may I pose a question about something that I'm genuinely just confusing in a whole?
Yeah.
Thank you. I'll try and get a picture. Finally, I have some time, so
Yeah,
I'll
good.
post
Yeah,
one.
post it. We'll go through it. Don't worry.
What's the line? What's the line like right now? What's the line that I have to?
It's like 4 people. Yeah. Well, 3, because V Sigma
I'll
submitted
get it.
this yesterday, but this looks like analysis that I don't really know how to do. Try to construct a function that depends on f. Find f such that... Also, I can't really read this. 3... Is this 3f of 2x is equal to 2f of x plus f of 4x? For all x that are real?
Hey.
Oh, that's cool. All right, we can look. I'll look at that in a bit. Hint: try to construct a function. Okay, go find it. Let me see if I can help this one. I never actually took statics, and moment, to me, like, moment refers to, like, torque. I know in statics, it's because things aren't moving. They call it moments. But in my mind, I feel like it's the moment is equal to, like, it's like F perp times R, right? And so if it's about point A, and if the force is pointing, which direction is the force pointing? Is the force pointing completely in the X direction, the J hat direction? Yeah, moment's just the torque, right? Yeah, okay. So I only care about the perpendicular distance to this, right? Which is 2 components. So you have perpendicular in this direction, and then you have perpendicular up, down. I assume the force is... Yeah, thanks, Effie. Yeah, I assume the force is only pointing in the J hat direction, right? Or I guess... Well, they're calling it, like... I think this is Y. It's pointing towards E. Okay. Oh, so then it's not, right? Will I be able to do the organic chemistry? I will take a look at this. If one of my organic chem friends shows up, let me see if JC's. Where's JC? JC might be sleeping. But if not, Shaz, what will happen is this will get put into our Discord. So all the questions that get asked today, even if we don't answer them, get put into our Discord server, and I will tag the chemistry people. We have, like, a team of what I call the chemistry gods, and they might be able to help with this. Off the top of my head, yeah, I don't know how to do this, but It looks cool. Yeah. May the force be with thee. What's up, coolest dude?
Good job.
Okay. So point E. I think I want to put things in terms of vectors, David. Right? Yeah. So if we call this like 0, 0. 0, 0, 0. Right? This is the origin. Yeah, I know you want to understand. Yeah. Yeah. So we're gonna try to understand. Yay, JC just joined. Oh, look at that. Oh, he is here. Yeah. Okay, awesome. Yeah, JC. This question, I was literally just about to tag him, dude. JC's right here. A bunch of Canadian kids starting OrgoChem right now. Nice. Okay, cool. Shout out to JC. JC's great. So actually, Shaw, you're in luck. Here, JC, I'll put this one already in the Discord. If it's OChem 2, do you think you can solve it, JC? Synthesize the molecule from benzene. Oh, he says he can. Okay, so here, what I'm gonna do, I'm gonna put that question in our Discord just real quick for Shaw's. One sec. So Shaw's, you're in luck. This is gonna get put right here. So in our Discord, in the homework help forum, you'll see there's now a post with your question on it. And if JC still has some awakeness in him, because it's really late for him, he's in the UK right now, maybe he'll write down some comments about like how to do this. But that'll be here. So make sure, Shaw, if you want to go join our Discord, the link is there on the same page you used to submit the question, and you should be able to then like connect with JC, the CEO of chemistry, in our server. Okay. Let's see on this one. So I'm gonna call this the origin. So let's figure out like where this point is, right? Where point F is. English homework makes me mad. I agree. Let's see. Okay, in terms of X, I feel like this point is 200, 200. I think it's 400, right? It's 400 down. Which, I mean, doesn't look like that from like to scale, right? Because this says from here to point E is 600. Right? But I could have sworn that this looks closer to the origin in terms of X. Cool. All right, so there's bro. Yeah, here. And I'll ping the chemistry gods. There you go, bro. Got you. But okay, from the diagram, I just have to go off what we have here. I think this is at 400. Right? So if this is at the origin, then F is acting at 400 in the X direction. In the Y direction, I think that's also 400. Right? And then in the Z direction, I believe that's 200 below. So I think this is negative 200. Right? So this is like point F. Actually, so I shouldn't write this as a vector. Sorry, I should write this as a point. Yeah? So then let's figure out where point E is. Right? So E is located at 600 in the X direction. 200... Sorry, no. 0 in the Y direction. And then 200 positive in the Z direction, I think. Does that seem right, David? I'm just trying to like. Jeff loves coordinate systems. He really does. Yeah, Shaw's. Is your name Bruh in my Discord? I think I see you already then. Yeah. Dun, dun. Okay. I think that's point E. That's point F. So then, you want if you want to find where F the vector, right? I saw that I have to obtain the force N between D and E. Between D and E. Yeah. Oh, sorry. Okay, so yeah, sorry. Point D is here, right? Point E is here, and then F vector is equal to E minus D in terms of points, right? Because it's, you know, it's the tail minus the start or whatever, final minus initial kind of type stuff. So this is E minus D, so that's gonna be 200, and then negative 400, and then and then 400. Okay. So that's a vector now. That is where the force is. That's the vector. Okay. So then the moment about a point is equal to R cross F. Okay. So it's equal to the cross product. Isn't F just 0, negative 100? 0? I don't think so. So Effie, do you agree here with what my points are for D and E? Okay. So then F as a vector, shouldn't that be E minus D? So it should be 200 minus 400 and then 400? For the forces between D and E is only J hat and K hat? Sure, okay. So you're saying J and K is so that there is no X component? I mean, it looks like this is pointing with some component in the I hat direction, no? This diagram is kind of like shit. Or I'm shit at reading it. Because again, I see that this is 400 in X, but E is 600 in X. So to go from D to E, you have to lose 200. Or sorry, you have to gain 200. Okay, let me see. I got 100. 100 divided by the square root. Now wait, why are you dividing by the square root? That's a unit vector. If you're doing that. Oh, because it's 100 newtons. Oh, yeah. No, I agree with that. Okay. Yeah, no, I see what you're doing. Yeah. I see. Yeah. Okay, so F. Yeah, I agree with that. I see, because you wanted a value for it. F is equal to 100, and then it's I would say line DE, right? Over the magnitude of DE. Yeah, I agree with that. Okay. But I think DE has all three components. There's definitely some change in the X in the I hat component. Because this only marks 400, this is 600. There has to be some component in the I hat component, I hat direction. Okay. I agree. It's just like, it is messy though, David. Right? Right? I don't know. It's kind of a messy diagram. If you show your work, your teacher, yeah, it's definitely not a straight line. Yeah, what? No. Yeah, that is definitely not straight, right? That looks like it's going up, and it looks like it's going to the right, and it's obviously like traveling inwards. So I think it has all three components. Anyways, okay, so that's vector f, and then the moment is r vector cross f. And then I think r points, if it's about point A, r needs to point from A to D. So r vector is equal to line AD, right? Which A, I believe, is located at 0, 0, 400, right? We agree with that for point A? Good, okay. So yeah, so then this is 0, 0, 400. Sorry. No, it needs to be D minus that, right? Sorry. It's 400, 400, and then, and then minus 600, right? I also want to upload streams of myself studying and long-form videos about me doing engineering projects. I can't get myself to start even with the free time to commit daily. Just set aside 30 minutes a day to just do something. Just build a habit. That's the best way to do stuff. Okay, so then you do this crossed with this, which is a mess. Now my question is, when they want the moment, is that just a magnitude though, right? Or yeah, the moment technically is a vector. But I'm just curious, David, in terms of like the answer your teacher's looking for, do they want it do they want it as a vector, or do they just want the magnitude of the moment? I guess you have to figure out the vector anyways before you can figure out the magnitude. Okay. It's in unit vector form. So I had J. Okay, that's fine. Cool.
Good job.
All right. Well, we need numbers for this. Which, kind of annoying. Any tips? Write things down. If you write things down, they're more likely to happen. That would be one of my number one tips. Cool, dude. Yeah, write stuff down. Where's my calculator, by the way? Where'd you go, calculator? Oh, there you are. Okay. So to get this, let's figure out the magnitude of this. So 200 squared. Also, technically, this is all in millimeters. You gotta go put it in meters, right? So this is really 0.2 squared, right? Plus 0.4 squared. Plus 0.4 squared. Square root of that is 0.6. Oh, that's kind of cool. Multiply that by 100. So you get 60. So this part right here, David, this is 60, right? And then it's times 0.2 minus 0.4. 0.4, right? It's actually kind of nice. So what? This is 12, comma, negative 24, comma, 24. So that's F. And then, right, because this is all millimeters. So this is really just equal to 0.4 minus 0.6. And so then you're going to do R cross F. Okay. Which you have to do this. So R cross F. You can make your little table like this. IJK. So then this is 0.4 minus 0.6. And then this is 12, negative 24. 24. So then cross products, I like to do the T method. So I'm going to like block this and this, and then I'm going to do this determinant. So what is that? That's 0.4 times 24 minus, right, because minus is there's so many negatives here. Minus 0.6 times 24. Okay, so you get negative 4.8. So it should be negative 4.8 for the first component. And then you take this, move it over here, and then you do this determinant. Mug says, what?
Surprise, motherfucker.
What's up, Mug? What's confusing, dude? So this is 0.4 times 24. And then minus, so then plus 0.6 times 12. But then the middle one is always, there's another minus sign. So this is minus 16.8. How do you solve the... Oh, sorry, my calculator's right here. Sorry. Zephy, I am definitely using a calculator. Sorry. I didn't have it on the screen. There you go. And then your next one is negative 24 times 0.4. And then minus 0.4 times 12. Right? So you get negative 14.4. Okay. I think that's it, David. Yeah? I think that's it. I think that is part A. And then if you wanted to do part B, your R just changes. So for part B, R vector is now equal to it's equal to ED. Oh, wait, should the moment be 0? Right, wait. Yeah, wait. If the force points in the direction of E, and then R is pointing from E to D, those are parallel lines. And parallel lines, when you take the cross product, are 0.
Huh?
So this answer is just 0. Yes, because it's along the line of action. That's another word that I've seen used before. Yes. So here, it's 0. For the moment about the line AB, I don't know how you do moment about a line, unless, do you find the midpoint of AB? Is that what you do? Do you find the midpoint of AB and then that becomes your R? Let me ask chat. I'm curious about chat. 1 second. If I want to find the moment of a force about a line in statics, do I just find... And it's really a line segment, right? It's a line segment. Find r vector as the midpoint of that line segment. Just curious. You do not use it. Okay.
Surprise, motherfucker.
Stop, Ron.
Oh, okay, here we go. You project... Okay, pick any point on the line. Form the r vector from that point to any point. Form the position vector r from that point to any point on the line of action of the force. Okay. And then calculate r cross f. And then you dot product that onto the equation of the line. Yes. Well, I don't know what big N means. So, so I think actually, well, because point A, right, is also on the line AB. So I think you just take your answer from here. So I think you just take this. It's the same thing, right? And then you're gonna dot product it with AB. And line AB was... Ooh, I don't know what that is, though. What is that? It's annoying. What's point B? B is located, I want to say, at 200 in terms of X. 400 in terms of Y. And I want to say 200 in terms of Z. So, AB is equal to negative 200, negative 400. Right? No, sorry. B minus A. Not A minus B, it's B minus A. So it's 200, comma, 400, comma, negative 200. Yeah. There you go. Or, and I should do these in actual meters. So 0.2, 0.4, minus 0.2. So then you're going to take this, and you're just going to dot product it. I think. And then that moment won't be a vector. Right? Because that's a dot product. So that's going to be a scalar. And I think that makes sense. What's my U line though? I think the U line is AB. Oh wait, but does it need to be a unit vector? Oh, okay, wait, sorry. So sorry, it's this, and then this has to be over the square root of 0.2 squared plus 0.4 squared plus negative 0.2 squared. Okay. Which, I don't know, what is that? Didn't we just do this one? Like 0.2 squared plus 0.4 squared. Plus 0.2 squared. And the square root of that? Ooh, that's ugly. 0.489, 0.49? That's so ugly. Okay. But yeah, just do this. I think you should get the right answer. Do you know how to do dot products, right? You just do this times this, plus this, times this, plus this, times this. I think that's what it is. Cool. Okay, nice. All right. Good question. Statics.
Well done. Well done.
I never took statics. That's an engineering class. I took, you know, physics. We just use torque for everything. Yeah, you're very welcome, dude. All right. That was David's. And I'll post a solution in Discord for you. Let's go see it. David the cool cat. Let's see what else we got. Wait, where'd all my questions go? I thought for sure we had more. Oh, Mahmood? Okay, let's do Mahmoods. These are fun. Looks like, and I appreciate JC. JC's really helping out Shaw's with the OChem one here. Doing God's work in OChem land here. This is really cool. Good job, JC.
Oh, yeah.
Appreciate you. Okay, let's try to do this one. This is from Mahmood. This is physics. An airplane flies. What's up, Meltorrent? What's up? I am Unk at this point, I guess, yeah. From Edmonton to Calgary, and it continues from Calgary to Vancouver. Using components, calculate the plane's total displacement. Wow. I always get confused at what the notation for this. This problem assumes a flat Earth. Oh dear. Yeah. Okay. When they say like west 76.7 degrees south, I think that's 76.7 degrees south of west. Right? Is that the heading notation? Yeah. So I think it's like this. Bring up the two Canuck cities on a map to find out. From Edmonton to Calgary, I guess. Yeah, okay. Well, we can look it up. Okay, so if this is 76.7 degrees. Yeah, let's go look it up. Edmonton to Calgary. Wait, no, not this. Edmonton to Calgary. Yeah, that kind of looks like 70 degrees south of west, right? It's definitely not 70 degrees west of south, right? Because that's pretty like straight down. Takes about 3 hours apparently. Yeah. Yes, it's mostly south, which would make sense that it would be then 76 degrees south of the west. Yes. I agree. Yep. Okay. So let's do this. So this is actually probably what it really looks like, right? Okay. If you want to break that up into components, not too bad. We can just do this, right? So, and here, let's say we're doing for question 1. So the y component is going to be sine of this angle, sine theta, because it's opposite of our hypotenuse and it's negative. So you have 276.9 sine of 76.7 degrees is the y component, and that's going to be negative, right? And then the x component would be the cosine one. Right, and this would be cosine of 76.6. Right, so this is x, this is y. And then the next one is 11.45 degrees south of west. Okay, cool. So that's then going to look something probably like, and that's even more. That's like 600. Wow. Okay. So actually, here we can make a thing here. So then this one is 11.45 degrees. Vectors! What's up, Zach? Yep, someone's asking about vectors. Good to see you. Jeff is upset that we're not doing this on, like, spherical geometry land. Oh. Shout out, Zach. I love 3 times 10 to the 1 as an answer. Just write 30. Yeah, bro. Put the fries in the bag. Yeah. What? Just write 30. It definitely would have an effect. Yeah, no, they are pretty long. Okay, so then this one has components that look like this. So I would say this one has X component, which is equal to 675.1. Also, these are also negative, right? Because you're going to the left in terms of X. So this is also negative. And then this would be cosine of 11.45 degrees. And then the Y component here would be negative 675.1 sine of 11.45 degrees. Okay. And then we're going to like add these up. Okay. To get our total displacement. Yeah. This is like the resultant vector. Which would actually just be kind of like putting these two on top of each other like this. So then this is the resultant vector. Okay, so this plus this, let's get some numbers. Need a calculator for this. So negative 276.9 cosine. Let's make sure we're in degree mode. Yeah, good. You gotta be careful there. Cosine of 76.7. And then this is gonna be minus 675.1 cosine of 11.545 degrees. What's up, Bello? What's up, nerds? Nerds unite, dude. So this is negative 725.36. So here, x negative 725 point, let's say 37. Whatever, close enough. All right, and then we got to do the same thing. But we got to do a sine. So I think I can actually just take this. This is actually really cool with the calculator. And then I can just replace this with sine. And I can replace this one with sine. And then I don't have to type in all of this stuff in again. Nice. And that's negative 403.49. Where are you from? I'm streaming from Los Angeles right now. Right? Cool. All right. So then if we want the total displacement, we have to square these and add these, right? So that's going to be the square root of this squared plus this squared. So let's see. This. Now it's going to hold the negative, right? So I have to multiply by -1. Oh, that's annoying. Okay. And we're going to add that to... We'll just type it in. 403.49 squared. And then square root it. What's the website? It's right there. actualofficehours.com. There's a link right down there. Cool, we get 830, which is actually exactly what they got as well, right? Look at that. Yeah, so also we got 830. Nice. Okay. And then if you want the angle, right? Well, I know now what the total component is in terms of y, and we know what it is in terms of x. So this angle is always just like the arctan of the y component. That's the opposite over the adjacent. Do you do chem? I definitely do chem. Yeah. JC likes chem as well, if JC's still awake. We were just, JC was helping someone out with OChem today. Scary stuff. But I can help with like Chem 1 and Chem 2 stuff. Chem 1 and Chem 2 I can help you out with. Alright, so let's do the arctangent of 403.49. You don't like Chem? I like Chem. I think Chem's great. Chem's cool. Chem's cool. You probably just don't have a good teacher for it. That's unfortunate, though. It's high school level. I can definitely help you with high school Chem. That's okay. Good. I have a question regarding the dx1 and dy1. Why do we make them negative as well? They are negative, right? Mahmood, isn't this... Sorry. This is negative, right? This is negative. This is negative and this is negative. Or are you talking about like... And this is negative. But when we go in and we do the square root of them squared, the negatives go away. Now, when I do arctangent, I use only positive numbers for everything. What's up, Rex? Because, and then I look at the picture to figure out what the angle should be. I wouldn't call my teacher a teacher to be honest. They're learning it with you. Oh dear, that's unfortunate. Yeah, okay. So when you take the arctangent of that, we get 29 degrees. So I think what we got, yeah. So then the angle is equal to 29 degrees. And then in fancy heading form, right, you would say that is west 29 degrees south. I think this is the fancy way to write it. Yeah. Yes, west 29 degrees south. There you go. We got it. Nice. Cool question. Your school hired them off Craigslist?
Surprise, motherfucker.
Oh, dear. Okay. I hope that helped you out, Mahmood. It's similar for the other ones. This one you have like 3 vectors actually you have to do. But same thing. Just break it into components. Add the components up to get your resultant, and then you can find magnitude doing the square root of the component squared, summed up, and then you can figure out the heading by just doing the arctangent. Do you work out? I definitely work out, Faizan. What? Yeah. I'm gonna go work out today, hopefully. You're very welcome, Amir. Do you lift, Faizan, dude? Do you even lift? Okay, let's post that one in our Discord. Post. Sick. I need to go back. You're just recovering from an injury? Yeah. I kind of messed up my rotator cuff because I was benching like 250 and one of the weights was on the wrong side, so it was like unbalanced, and like I pushed through it and I shouldn't have done it.
Huh?
So I'm also kind of like recovering from a little bit of an injury. Okay. But let's see what we got next on the queue of questions. Ooh, name the following alcohols. Cool. Benching doesn't accomplish work though. So my most is 315. I did 315 bench on in December. It's on my Instagram somewhere. Where is it? Things want to load. There we go. It's all the way at the end. Yes, this is me. 3 plates. 1, 2, 3. Each of those plates is 45 pounds, which I think is like 22 kilos for you European people. Work equals force times distance. I'm definitely applying force to do this. But I only did one of these. I got one. I was just happy. Very happy I got one. Yeah, it's hard. But yeah, I fucked up my rotator cuff. So I want to get back into benching. It's probably going to be another week or 2. You do need distance meltered, yeah. Based. Where was that question from Gladiator? Sorry, here it is. Thanks, Faison. Alright, let's name. Ooh. Okay. Yeah, so alcohols have hydroxide groups on them, right? And they always end in all. Let me think. This is cyclo something. Is this hexanol? Is this hexanol? Looks like hexanol. Let me see what hexanol looks like. Man, I miss physics chem. I miss physics. Chem made physics enjoyable. That is true. Oh, sorry. Cyclohexanol, I think is what it is. Sorry. Cyclohexanol. But what if there's 2 hydroxides on it? Oh, okay. This is what it is then. JC says cyclohexene 1,2-diol. Oh, and he's correct. That's why they call him the CEO of chemistry. Yeah, so this is cyclohexane. And then, yeah, the 1,2 refers to, like, where the hydroxide groups are. So you can think of this as, like, 1 and 2. And the rule in naming chemistry stuff is you want it to be, like, the least number possible. So, okay, this one... Let's see. So 1 carbon, 2 carbons, 3 carbons, 4 carbons, 5. Right? So I know it's gonna be pentanol, right? Pentanol is kind of like the base. And then I believe the counting has to, I think the preference is this is always 1, right? So then if I'm labeling where these additional methyl groups are, right? Because this is an extra carbon that's just chilling on it. It's an extra methyl. That's going to be 1, 2, 3, 4. So 3 and 4. So I think that's 3, 4 dimethyl pentanol. Correct. JC agrees. Nice. Okay. This is interesting. Because the hydroxide... So there's definitely a carbon here, right? We got a carbon here. I got a carbon here. So I think this is... So 2 carbons is ethyl. So ethanol. So it's ethanol for sure. But then there's a single carbon. So that's a methyl group on the side. So I think that's going to be 1 methyl ethanol. Is that correct as well, JC? Yeah. This one's weird. Dang. That's technically not. It's technically not wrong, but it's more correctly as propan. propan-2-ol. Oh, really? They put the number in between there like that? Propyl. Propyl means there's 3 though, no? Right? It's methyl ethyl propyl butyl, no? Or isopropanol, your favorite for 3 carbons. Oh, you're right.
Good job.
I don't know why I saw this as just like 2 carbons and then another one attached. Okay, you're so right, actually. Sorry. There you go. Yes, propyl makes sense. Okay. It is propyl because there's 3 carbons. I agree with that, Hamilton. Thank you. And then, yeah, okay, so propan-2-ol. The 2 marks that the hydroxide group is on the 2nd carbon. Or, yes, I guess isopropyl. Isopropanol? Your favorite rubbing alcohol. Yeah, don't drink this, though. You'll go blind. Okay. All right, so this one, I know this is going to be this is a diol, right? Because I have 2 hydroxides. Why does isopropanol work? This is just a common name for it, I think. I think there are like certain like special names they have for things. Like here, isopropyl is just this. I don't know why they put the iso on it. I think it's a common name for it. Oh, okay. In an isopropyl group, both sides are equal. Okay, that makes sense with the iso part. Iso means equal or same. I see. So what they're saying is that the hydroxide group, the alcohol, splits the carbon chain into 2 equal parts. So that's why it's called isopropanol. Nello says, damn, y'all are starting on organic chem. That's our last unit. Yeah. It is kind of the last unit in general chem. Iso is also because it's the isomer of normal propyl group. Okay, I can see that as well. This one, I'm pretty sure is a diol. Yeah, so we're definitely gonna say diol. Man, but so this is pentane. And then let's see what this is. So this is like what's attached to this? This is carbon, 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 carbon. So is it methyl? So that's butyl. This is butyl. But then where do you start counting things? I want to say like cyclopentane. And then I want to say start counting from the leftmost butane carbon. So that's this one. And then so I'd say 1, 2. The entire group is called cyclopentyl. Oh, I see what he's saying now. Oh, this is actually really cool. Okay, no. I got you. Yes, okay, so the 1,2 diol. Right, you're calling this 1, this is 2. And then this is called a cyclopentyl group. So it's 1 cyclopentyl. 1 cyclopentyl butane. Cyclopentyl butane. Dash 1,2 diol. Yeah, okay. Does that make sense? So this is the main butane carbon chain we're talking about, and then this is like an attachment to it, which is called a cyclopentyl attachment. And then that's on the first carbon, because that's where the first hydroxide is. And then yeah, 1,2 diol. Yeah, Very cool. So, ooh. This one. What happens? This is hexene. Is this? Is it cyclohexene? Or benzene? Or I guess it's benzene, yeah. And then I assume this is the first carbon. As a side chain, it's called phenyl. Oh, okay, cool. So this is phenyl. So I think you say one phenyl. And then that's ethanol. Phenyl. Ethanol. Nice. Yeah, because you got 2 carbons here, so that's ethane. But with the hydroxide, it's ethanol. And then this is called a phenyl group. Which I think, these are called like aromatics, right? Aromatic rings. Because they smell nice. Don't go sniffing benzene, though, or gasoline. It's not good for you. What is going on here, though? What? Excuse me? Is this carbon? This is another carbon. This is another carbon. So, this is where I want to say iso. I want to say isopropyl. Isopropyl diol. Can I say that? Is it isopropyl diol? You can call that propane 1,3-diol. Wait, whoa. Propane. Wait, where's the 3 coming from, though? Oh, 2,2. Okay, all right, much better. Okay, yeah. All right, that makes more sense. Okay. Propane 2,2 diol. Okay, I agree with that. Yeah. So I don't think it's this one. Is isopropyl diol even a thing? What's isopropyl diol? Apparently not. Nope, not a thing. I'm just making up chemistry things in my head sometimes. So this is propane 2,2-diol. Okay, great. This one. So this is a double bond, right? So this is carbon-carbon. So that's ethene. I think it's ethene. And then I would say 1,2-diol. I think so. Ethene 1,2-diol, yes. I don't know how specific this, but this is the Z isomer. Oh, I see. Okay, yeah. Gladiator is asking, do we have to say cis trans for this? I think this would be cis, right? Because they're on the same side. I think trans would be this one. How hard is it to gain this nomenclature knowledge? Yeah, so this is cis. I think this one is trans. Before all the bathroom fights started. This was the OG cis and trans. OG cis and trans came from chemistry. How hard is it to gain this knowledge? I don't know if it's really hard. It is annoying. It's just like a standard. There are patterns. But then there's also like a hierarchy of like how you're supposed to name things. And which things take preference. Like which numbering things do you really want to prioritize? What does cis and trans refer to? Yeah, so cis refers to the hydroxide groups, being on the same side. So I think if we were to look at this in terms of like a Lewis structure type thing, this would look like this, right? And then this needs to have an extra hydrogen here, an extra hydrogen here. Yeah. I believe I don't know, maybe this has like some lone pairs on it. It's got to have some lone pairs, right? Does it have 2 lone pairs? I think so. But yeah. So this is cis. Whereas that's the thing with chem, it's less analytical than physics. Yeah. To me, it's a nice in between for instance, biology and physics. Biology and physics are on like 2 opposite ends of the spectrum, right? Biology is all very like kind of like category stuff and memorization, right? But sorry, this is not cis. This is trans. Yeah. Trans means like transversal, like across. Like transcendental, I guess, you know. Cis, you'll hear this all the time when they say like cis males or whatnot. It just means like normal, I guess, or the same side. Cisgendered, right? Is that what they call it? Cisgendered? I don't know. What stops that from spinning freely about the double bond? Probably some interactions between the electron clouds, I would imagine. Exactly, yeah. Some chem can just be done with like feel and intuition. Like there is kind of like a feel and an intuition to this, and also, yeah, things just kind of look pretty. You're just like, oh, I can kind of make it. Yes. So JC says a double bond. This has a pi bond, so this has a sigma bond and a pi bond, and the pi bond cannot rotate, and that has to do with the electron clouds and hybridization and all sorts of things, orbitals, right? So it's either stuck in one of these configurations. Yeah, it's not. Yeah, TikTok's being weird. Mathematic fanatic. I've tried today. I don't know. They change their rules on like what APIs I'm allowed to call on it all the time. So it's not working today for the multi-chat. Yeah, unfortunately not. Did I skip F? Oh, I did. Oops. Okay, sorry. Dude, what is this? Ho 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 ho.
Bruh.
What about optical isomers? I don't know about those. Maybe JC does. Is this? Sorry. I know diol is 2. What's 4? Is it like quadrol? Enol? Is it enol? This is definitely ethene, for sure. But then it's like 1, 1, 2, 2. I don't know, like quadrol. Is that what it is? Oh, it's tetrol. Oh, yeah. Okay, tetrol. Or is it just called tetrol? Oh, okay. Ethene 1122 tetrol. Nice. Okay, cool. There you go, Gladiator. Cool questions. Oh, Chem. Big thanks to JC, by the way, for helping me out with chemistry, or definitely this organic chemistry stuff. I have to wait 32 seconds before giving JC another shout out. I want to keep shouting him out. What's wrong with that? Come on, Twitch. Okay, but there you go. What is petrol? Petrol? Petrol's different, dude. What? All right, let's post. That was Gladiators. Yeah, JC's great. You're very welcome. Bum, 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 Petrol, isn't it that British gasoline thing? All right, let's see. Faison says, fun to try. Solve for all real numbers. What's up, Ethan? Such that, what? Excuse me? How does this work?
Is that my turn too?
Is this your question? Night Rex. Rex, are you like, you're peacing out? You're just like,
You done messed up, AA Ron!
I'm down. I'm out.
Oh, I know that where that came from, but this is not my question at all.
Okay. Well, man, what is this?
I put it in like the
Okay, I'm sleeping. All right, thank you, JC. Thank you, JC. Let me shout you. I think I can shout you out again. 1 sec. Because now I think it's been 36 seconds or whatever. Oh, we were saying goodnight to JC. Got you. Yes. Good night, JC. Appreciate you. Okay. How do you check your spot in the queue? You're probably next. Yeah, Melter, you're number 3. This is number 2. V Sigmas I haven't done yet, but yeah. We'll do this next.
I have like
Ethan, you gotta put the question in the queue. You gotta put it in the queue.
I put it in like the home account thing. I thought that was where we're supposed to go.
No, that's the old system. I guess. Yeah. When you've been here since we introduced the queue.
Hey, I can't keep up over that.
I know. There's a lot of things. It's easy. Just use the website, actualofficehours.com, and just put the screenshot in there. It's because we're on so many different platforms at once that I have to come up with something that everyone can just like put into one place.
Hold on, let me see if I can copy the image instead. Because
I think you probably can.
So I can hold on. Let me see. And where do I put this thing? Like the copied image?
You put it in. Yeah, you put it here on the website right there. No, not in the chat. To that website. Go to that website.
Yeah, I'll go in there. And like, drag and drop your image here. There's here.
Yeah. Fnatic says it could be x equals y equals -1/2. It says solve for all real numbers. But yeah, what I want to look at this is I see 16 as 4 squared, and then 4 squared to a power. I think you just multiply the powers, right? So is this 4 to the 2x squared plus 2y? Plus 4 to the 2x plus 2y squared is equal to 1? Which I mean, wait, I could have just said this is 2 to the 4th. Why did I say 4 squared? Damn it. Okay, whatever. Okay, so then this is 4 to the 2x squared times 4 to the 2y plus 4 to the 2x times 4 to the 2y squared is equal to 1. It's a damn shame I can't just like take the logarithm of everything, right? What's up, Zach? What do you want to say? Is this your question, Zach? Or is this Zerudo? Oh, what's up, Zerudo?
Yeah.
Yeah, come on up, Zerudo. What's going on, dude? It's crack-lacking.
Hey, man.
Hey, man.
Good job.
Welcome back.
Yeah.
We're doing some math right now. How's life?
No. It's been good.
That's good.
Ups and downs.
Dude, life, Ethan was just telling me. Ethan's like, I feel like things have been going down sometimes. I'm like, yeah, it happens. There's
But
contrast.
then there'll be times when it goes up. There'll be times.
There are always times when it go back up. Yeah, 100%. You need the low times also so that you appreciate the up times.
Yep.
I feel.
That's a good.
What's
It
up,
would take
Ethan?
me quite a while to like get like the original image. So I'm gonna have to send like some blurred out image.
Okay.
I'm not sure if I could just decrypt it for you, but I'm not sure if it would be the best instance.
It's okay. Just put it in. Zach
I'm trying
says...
to.
Oh, I have two Zachs, right? I have Zach here in my stage, and then I have Zach E the 2i Pi on my Twitch. I'm surrounded by Zachs today.
My twin, man.
My twin. But Zach E to the 2i Pi Zach says we could try dividing 16 to the XY on both sides. Okay. The reason we can't use logs, Gladiator, is because it's log of like the whole thing. I want to like do this. I want to do log of like each individual thing, but I can't do that. Isabella.
So I sent the thing in already.
Nice. I see it, Ethan. I see it. You're good.
I'm gonna have to help you to cut that thing though because it looks a little blurred.
This Zach spells it with a K. I think. Oh right. Yeah. Zerudo, you spell Zach with a K, right? Z-A-C-K. Yeah. I think either 2i Pi. He writes it with an H. I'm pretty sure. The H Zach versus the K Zach. Let's see what Isabella has. Isabella says 6x squared plus 16x. Wait, what's this? Isabella, where'd you drop my chat? Excuse me? Yeah, this isn't turning anything into not turning into anything nice. I like the idea of like divide by 16 to the XY on both sides. The gold bedazzled water bottle, of course. There's a theme. Okay, this is equal to 16 to the x squared, 16 to the y, plus 16 to the x, 16 to the y squared. And then we're dividing all of this by 16xy. Ooh, I think I see something.
Good job.
Watch what happens here. Actually, let's just leave this. Sorry, let's leave this. I should have just left this as this. I see what Zach's doing. Zach's clever. This is y squared plus x. When we do this, oh, Isabel says that's what you want to solve? Okay, maybe. Well, let me see. Because then this is 16 to the x squared plus y minus xy plus 16 to the y squared plus x minus xy. And then this is equal to 16 to the minus xy. Yeah, I was hoping this. I kind of see what you were. I think you were hoping this would turn into like a trinomial or something. Isabella seems to think we're just solving this. Wait, 6x squared plus 16x plus y squared plus y equals 1? That's where this comes from? You think so? Wait, let me see what was... Wait, let me go find the YouTube chat. Go find it. I need to like make this bigger. How do I make this bigger? Descendant Fonts, what's up? This is what Isabella said. I'm curious where that comes from. I think if we multiply everything by 0, it'll be... No, you can't just do that. You can't just multiply everything by 0. That's the sledgehammer technique. Just be like, screw this.
Huh? You done messed up, AA Ron!
I'm just gonna hit it with the 0.
That name's not AA Rondo.
That's not gonna do it. Okay, I'm gonna. We'll come back to this question. I don't know exactly how to do this one yet, but it is fun.
Oh, I shall go for now. I'll return.
Okay, good to see you, Zerudo, dude.
Can I just do my question because I'm getting a little tired of sleepy over here.
Okay, all right. Well, one sec. Let me do Melturd. Faizan, this is fun, but I haven't gotten to it yet. The equation is 6x squared plus y squared plus 16x plus y is equal to 1. Oh, are you doing completing the square, Isabella? Is that what that's what you're doing? Oh, yes, that is how you complete the square. Oh, is that what you're trying to do? Are you trying to complete the square here? Or is it a different question? I think maybe Isabella's talking about a different question. 'Cause I don't see any 6s coming up. But the 16 gives me hope. All right, here, let me help out. Let's do this one real quick. This is actually fun. I like chemistry. And then Ethan, I will help you out. Don't worry. Okay. Meltard says the molecular weight of water is 18.02 grams per mole. How many moles are in 24.3 grams of water? Oh, okay. This is just stoichiometry. So you always say like question mark what you're trying to get. So in this case, it's like moles of H2O, and then is equal to what your starting thing is, which is 24.3 grams of H2O. Okay. And then you need to multiply this by some sort of conversion factor that will eventually go from grams of H2O to moles of H2O. And the conversion factor I see is this, the molecular weight. So this tells me that 18.02 grams of H2O is equal to 1 mole of H2O. Which you can write this as a fraction, right? I could just, do you see how like I could move this over to this side? And then that's also equal to 1. Oh, it's the AMGM inequality? Oh, wow.
Good job.
Arithmetic mean, geometric mean, that's a cool one. So, because this whole thing is equal to 1, when you multiply anything by it, you don't actually change intrinsically what the value of the thing is. You change, like, the representation of it, but you don't change how much is actually there. So, yes. So, in this case, so this is grams over moles, but I want grams to cancel out. So, I want something over here, grams, and then I want this as moles. And what I know is, right, is that 18.02 grams of H2O is equal to 1 mole of H2O. And now this is correct, Isabella, right? Yep, because just multiply top by top. This is technically 1 on the bottom, bottom by bottom. And then you get, like, grams of H2O canceling with grams of H2O. So, yeah, 24.3 divided by 18.02, which is equal to, yeah, approximately 1.35 moles. Nice. Cool. Thanks for helping out that one, Isabella. So it's literally just conversion bridge, but my teacher can't teach shit. Yeah, well, okay. That's what you get for hiring your teacher off of Craigslist.
Surprise, motherfucker.
Yeah, it's just conversion stuff. Not too bad. If you have any other things that you want to learn, I'm more than happy to help you, Meltard. Just submit questions with it. Maybe it's just her. Yeah, no, Chem isn't that bad at all, dude. Chem's great. I do think it's unfortunate when certain topics get a real bad rap because they just have poor teachers. You know, like people just don't know how to teach it correctly. I will say that that's kind of what happened to me with astronomy. I don't like astronomy because I had like a really bad astronomy teacher in my first year of undergrad. So kind of ruined it for me. So hopefully, you know, watching these streams and, you know, getting help will regain your confidence in certain subjects. More chemistry. Astronomy, the study of straws. That's true. Straws. I mean, there is like string theory. Can't there be straw theory? Meltard says she's gone 0 for 3 correct answers. She tried explaining. Oh, dear. Oh, dear. All right, let's see. Ethan, you're next. Okay, cool. Which one you want to help with, Ethan? All of them?
I was asking for help with like, no, not all. Just 1 and 4.
Okay. Let's see.
It's just take like the most time out of them all.
Okay, so x to the fourth minus 2x to the third minus 7x squared plus 8x plus 12. Is that what it is? Is less than 0?
Yes.
Okay, cool.
Yes, that's what the problem states.
All right, let's do it. So anytime you have these inequality things, I just pretend this is going to be equal to 0. And then we're going to try to, we're going to figure out where it's equal to 0. And those are called like critical points, which we're going to put on the number line.
Values.
Good. Critical values. That's good. And then we're going to test in between the critical values.
But see, that's the thing. You need to get to the critical values first. It's
Right,
not there immediately.
It isn't. Yes. Jeff says rational root theorem. Right. So the rational root. Yeah, zeros, roots, all the same thing. You could like write out like all the factors of these and all the it's like all the factors of these divided by all the factors of these, which is annoying. So I just always guess. I just guess. Like 1 usually works.
What?
Yeah, let's just try 1.
Usually.
Right?
Well, not all the time though. Not all the time it will work. The same.
Well, let's see. Let's see 1. Does 1 work? Okay, so 1 minus 2 minus 1 plus 8 plus 12. Well, that doesn't work. Okay, so maybe negative 1.
Oh, wait. You're going too fast. Wait, where did you just get those numbers from?
So I just plugged in like 1. I plugged in. Oh, I plugged in 1. I plugged in 1. I plugged in 1. I plugged in 1. Yes, sorry.
I think I would do that on the
1 minus 2 minus 7 plus 8 plus 12. Yeah. It still doesn't work though, Jeff. Let's try putting in negative 1. So, if x equals negative 1, right? So negative 1 to the fourth would be positive 1. Negative 1 to the third would be negative 1. But then you have another negative. So then this is plus 2. This is still minus 7. This is then gonna be minus
1.
8 and then plus 12.
It should mean 15.
So let's see. 0, right? Does this work? So wait, 3.
Yeah.
Minus
3,
7.
15.
Negative 4. Negative 4 minus 8. Negative 12. Negative 12 plus 12.
Yeah.
0. It worked.
That's dope.
So that's cool.
I found one thing. See, that's the thing. I like that is the easier step for me, because you could plug in a number, you find if it equates to 0, but what do you do after that?
I'm gonna show you. Okay. So this is actually, and this is a great. I have this video on my TikTok if you want to go check it out. I'll go through the steps of it and like why it is. That's dope.
That's dope.
But it's also under, man, what video is that called? How to factor really big polynomials. This video right here, how to factor really big polynomials, shows how you do it for literally like big things like this.
Oh gosh.
So you should just watch this video at some point, but I'll still do it for you here. I'll do it. Okay.
So see, yes.
So I know negative 1 is a 0. So this whole thing, right, has to be equal to negative 1 being a 0. So if negative 1 is a 0, that means that it could be written as x plus 1 times something else that's like kind of like left over, right?
What?
Okay, so negative 1 is a 0, right? Do you see how like if I plug
Yes.
negative 1 into here, I would get 0?
Yes, exactly.
Okay. So I know that x plus 1 times something else must equal my original expression, because negative 1 is a 0, which means that x plus 1 is a factor.
So that means that how like the other things you have to find the other numbers, the other real numbers.
Yes, but there's an easy way to do this, which is, since I know that this can be written as x plus 1 times something with like less crazy exponents, you can actually divide this whole side by the x plus 1. So you could do this, and then you can figure out what the simpler form of this thing is.
See, I did a prerequisite to this. I used to be so good, but I just forgot because I'm done.
So this is
Okay.
So you can either do synthetic division or polynomial long division. Which one do you like?
I like long division much better. Like
Okay.
well, not because I just learned it first, but it seems like synthetic division is just ridiculously like confusing. I don't like the fact how
it's
they put just
counterintuitive.
constants.
Yeah, but it is faster. It's faster for sure. But anyways,
It's not faster to me. I solve it in my own time. I'll take my time. I could take
Okay.
a whole hour for one solving this.
All right, here we go. All right. Isabella's just speed running
It's
through all the critical points. All right, so here we go. So I say, how many times does x plus 1 go into x to the 4th? That goes in x to the 3rd times, right?
You have to do just x though, right? You just have to do the first factor. Right?
Yeah. Well, you just deal with this one. Yeah, exactly.
Yes. And then you multiply. That's where you
Good.
start the
Then we
the
multiply this.
division
Yep.
process.
So then that becomes x to the 4th.
X to the 4th minus 2x. No, minus out.
plus x to the 3rd.
After that, you have to
No, I
make
love
that
Isabella,
thing
you're fine.
minus.
Well, good. Okay, so then we subtract this from this. Yes. So x to the 4th minus x to the 4th. That is going to be 0.
That's 0.
But then this is
But, like,
negative
wait.
2x to the 3rd minus x to the 3rd. So this is negative 3x to the 3rd.
Yes. But there is a question though. Why
Yeah.
is it that we have to minus it then?
It's just how like long division works.
Okay then. We just
You just
go
do it,
off
you
by
just
the
do it.
materials. Okay then.
Yeah.
So then you bring down the 7x squared, right? The negative 7x squared. Right?
I don't think we need that yet, because now we just figure out how many times does x plus 1 go into this.
Well, just x, but that would be negative
Mm,
2x squared, right?
no, it's negative 3x squared.
Whoa, what?
Because negative 3x squared times x gets
Oh,
me
yeah.
negative 3x cubed.
Okay, yeah, I mixed that up. I see where that
So-
goes.
I get negative 3x cubed, and then that's minus 3x squared. Yes, now you can bring down the minus 7x squared, right?
All right.
Yep, the rational roots would have worked. Yeah, I just don't want to test all these things. It just takes forever. Okay, so then I do this
And then,
minus
like-
this. That's 0, right? And then
Yeah, you have to
negative
minus it.
7 minus negative
Plus.
3 is the same thing as plus 3. Good. So then it's negative 4x
Yes.
squared. Good.
Negative 4x squared. Okay. And then you do the exact same process. So
Uh-huh.
that would mean that how you get negative 4x, right?
Negative 4x, correct. Okay.
Wait, but
So
then, see the. Oh, never mind. I'm mixing it up. Never mind.
No, it's okay. And then this comes down, so that's plus 8x, right?
Plus 8x, yes. Then you minus it again. You minus the bottom part, and then those cancel.
This
and
becomes
then
12x.
You get 12x.
Good.
And then you do the exact same thing. It'll be positive 12, just positive
Right.
12.
Mm-hmm.
And then what you do, that's those steps.
12x plus 12, right? It's 0.
And then you subtract.
Oh, yeah.
Yes, exactly.
So now you're good. Okay. So what that told
So
you,
you got
is that this thing here, right? The simpler form of this is this.
yes.
Okay. So now I'm left with, x plus 1,
And then that whole
this.
chunk.
Yes, but see, this is now easier to factor. This is actually, I think this is pretty to factor. Yeah, this is really pretty. You want to see why it's pretty? I love when I have 4 terms. Because what I'm going to do is I'm just going to group. I'm going to group them into like pairs.
Grouping. All right.
I'm going to
love
factor by
that.
grouping. So what's the biggest thing I can pull out of this?
X. There's an x. Oh, x squared. X squared.
X squared.
It'll be x minus 3.
X minus 3. Yep. All right, then let's
after
group
that,
this.
you put a negative 4. You do a negative 4.
Mm-hmm. And I think this is
it'll be
also x
X.
minus 3.
X minus 3, not plus. And then after that, you can just combine the x3 and then have the x squared minus 4.
Mm-hmm.
And
Good.
then I think I can figure this out for myself, because then
Yeah.
it's like, you just have x is equivalent to a positive 3 and x is equivalent to plus or minus 2, right?
Exactly.
That gives you the other 2.
Good. Okay, so now we have 4 roots, right? So
Yes, that's the
so
degree. It
x
follows the
equals
degree.
negative 1 x equals 3, x equals plus or minus 2. Good?
Yes. And then it's like, apparently, we have to create a number line and like point out the critical values and see which ones make the equation true.
Yeah, and this is where it'll help. This is where it helps for it to stay in factored form, right? So we figured out that this whole thing turns into this. So now, instead of writing this whole thing is less than 0, I can just write it in factored form like this. I can say, oh, x plus 1 times
X minus 3.
X minus 3. I don't know.
And then x plus
weird
2.
Colors. Sorry, yeah.
X minus 2 and x plus 2.
X minus 3, yeah, cool. Then x minus 2, x plus 2.
Yes.
Yeah.
Yes.
Cool. And then, so, on the number line, that means I have -2, -1, and then 2, and then 3, right? And this all needs to be less than 0, right?
You have to draw out what's called numbers. It's called smart over. You plug up equation and see the value between the ranges.
Yeah, exactly. So we're going to figure out, like, numbers in between. So a number in between -1 and 2 would be what?
0. Best solution apparently 0.
Yeah, 0. 0 is nice, right? So if I check 0...
If you plug 0 into that whole equation,
this is positive. Well, watch. You actually don't even need to know what it is. You just need to do positive, negative, positive. So this is positive.
That's the pattern.
This is negative. This is negative. This is positive. Positive times a negative is negative. Times a negative is a positive. Times a positive is positive. And is a positive less than 0?
Never once.
No. Right, so this does not work.
Disqualified.
Okay. So you
And
know
you just need to figure out the right side. What are the other sides?
Well, you got to figure out here, and you got to figure out here, and you got to figure out here, and you got to figure out here. You got to figure out a couple places.
But it's like you just have to follow the pattern. Like if that middle one is positive, and you just determine one of the sides, you know the
so
other
let's
side
see
will be the
if
opposite.
it was 2.5, right? This would be positive, negative, positive, positive.
Positive.
So this
The
is
whole thing just
negative,
becomes negative.
right?
Yes.
Which negative is okay,
And
right?
a negative is definitely less than a 0.
Mhm.
Wait, that before you continue, there's a question I have.
Yeah.
It's like I've heard before in math terms, 0 is neither a positive or a negative. Then how do you know a negative is less than 0 if it's not a positive or a negative?
Wait, what? Sorry, excuse me. Say
You
that
know what
again.
I'm trying to say?
No. Sorry, say it again.
Like I'm just saying, like I heard a math term where apparently like 0 is neither a positive or a negative number.
Correct.
But
yes.
how do you know? But how do you know if a negative is truly less than 0? That's one thing I thought about.
Oh, because it's negative. So 0 is not positive or negative, right? 0 is 0. But if you're less than 0, you're negative. If you're greater than 0, you're positive. It's like the boundary.
Get it.
Okay.
All right. Well, let's continue.
So we can check a higher value. I think Jeff has a good point here as well, that there's exactly one sign change each time. Correct, because there's no degenerate solutions, or there's no repeated roots. So anytime this thing crosses, it always does this. Like it always crosses the axis.
Yes.
You'll get into that eventually at some point, but for now let's just pick 5, for instance, right? So this would be positive. Everything's positive, right? But positive is not less than 0.
So that range cannot work either.
That is.
Then that means to the left side. That means that between -2 and -1, it's completely negative. I don't have to test it because I know the pattern is just going to be that same thing. And then
well, we should test
2
it though. So -1.5 plus 1 is negative. This is negative. This is negative. This is positive. Negative times a negative is positive. Times a negative.
Times a negative is a negative.
Which is negative. And negative times a positive is negative. Yes, this one works. And then
I don't even have to test it because I already know the pattern. This is just like you don't even have to plug anything because if you test it to beyond infinity, the whole thing's just going to become positive and will not be able to work.
All right, cool.
And so then you have to write this in an interval notation.
Yes.
Depending on
Isabella's got it
the
down.
original question, like And depending on the original equation, you can either have to put like square or circular brackets. You have to put circular brackets since they're not including the ranges of the critical values. That would be like
Yeah.
circular bracket of -2 to -1, close circular bracket, right?
Uh-huh.
And then the union sign, because it
union
could
sign.
be either or.
Yeah, it could be here or it
Circular
could be here.
bracket 2 to 3.
Nice.
Circular bracket 2 or 3. It doesn't include the 2 or 3.
Yeah, that's it. That's it. You're done.
Hey. So I think I
Nice.
can understand it now. I think when I come across problems like these, I could do it again. I think thanks to you, I
Nice.
just rebuilt my confidence.
Good, dude.
But there was one other question I wanted help with, like genuinely. I don't think
number
you would
4?
have time for that one.
Number 4?
Yeah.
Oh, I have time. Yeah, I thought 50 minutes. True what your mate said.
Sure.
Thank you, Isabella. Okay, yeah, so for this
Let
one...
me get the original image.
No,
Look at the original image because you might not be.
No, I can read it. I can read it. I know what you're saying. So this is x
Alright.
plus 1 over 2x squared plus 5x minus 3 is greater than or equal
Yes.
to x over 4x squared minus 1.
Yes. Now, see, this is where it's, I confuse everything because what's the first step and how do I even solve this whole thing?
I want to factor things is what I want to do.
Exactly. Why would you factor immediately before doing anything else?
Just because some things might cancel. So
Alright,
like,
Go
if
ahead.
this is x plus, so this right here, for sure, is a difference of squares. So this will be 2x
Yes.
plus 1, 2x minus 1.
And 2x minus 1.
Yeah, good.
Yes.
This is a little strange. So it's, I always do like this times this, which would be -6. And then what multiplies
Yes.
-6 but adds to 5?
See, it's like it's hard for me to remember that thing. It's like
-1
I
and
sometimes
6.
mix it up. Like
Well, here's what I do.
sometimes-
I do this. So once I know that 2 times -3 is -6, and that -1 and 6 add up to +5, right? I then put those on the
Huh?
diagonals. I say -1x, +6x, and then I put these things on the other diagonals. So 2x squared, then -3. And then
Alright.
my job is just to like factor out whatever's here. So if I want to factor something out of here, the biggest thing I can factor is 2x. And then it's like,
the other
okay,
one,
well,
it's
what
-1.
times 2x gets me 2x squared? It's like, oh, well, that's just x, right? And then it's like,
Oh wow.
x times what is -x? Well, that's -1. And then
X
it's
times
like,
what is all the
-1 times what is -3? That's just 3. So then now you have your factors, x plus 3 and 2x minus 1.
Nah, that's craziness. Nah, that's a technique I might not want to use.
Yeah.
Like, oh my
This
God.
one's great. Yeah.
It just confused me just now.
Well, so this is just this is basically factoring by grouping. It's just a different way to visualize it.
I would say like I would just like force the thing by finding like how you can multiply the brackets to get back the original equation.
Yeah, so interesting thing here, right? Yeah, we do have a common factor, right? 2x minus 1. I feel like I can just get rid of that one. I feel like I can.
How did you do that so quickly?
Well, just because it's 2x minus 1 is 2x minus 1 on both sides.
All right,
I can multiply both sides by 2x minus 1, right?
I guess.
We're just so there's some assumptions here, right? I don't think you're allowed to have x equaling a half as a solution.
I have no idea.
Not if 2x minus 1 is less than 0. Yeah, you're right.
Bruh.
I think
Let me
Jeff's-
just keep that there for now.
I think Jeff is right.
Just keep it there for now.
Yeah, x equals 1/2 is undefined. Bring it all to one side and combine. Okay, let's do that. So I think what
Yeah,
we're gonna do
because
is
apparently,
we're gonna move this over here.
Oh, wait, I would do that. I will bring the right one to the left.
Oh, we can do that as well. That's cool.
That's a better one for me. So then you have minus that whole chunk. Just call it John.
Mathematic Fanatic says Jeff is wrong.
Bruh.
You can cancel it if it's negative, just not if it's 0. I think the debate here though, Mathematic, is that if I multiply both sides by 2x minus 1, technically I'm multiplying by a negative. Don't I have to switch the thing? Or maybe not. Okay, wait. If 3 is greater than 5, and I multiply both sides by -1, is -3 greater than -5?
You switch the sign. You have to switch the
Wait,
sign.
no, sorry, this is false. Sorry. I don't know what the fuck I'm saying. Sorry.
Wait.
Sorry.
Wait,
3.
3 is greater than 5. Wait, that was
Sorry.
completely wrong.
This is a valid statement, right? But if I multiply both sides by -1, then I get -3 is less than -5. That's wrong. Technically, I would need to flip the sign.
No.
So,
yes, you need to flip the sign. Yes,
yeah, so that's the concern with just canceling this. Because if 2x minus 1 is negative, then technically I also need to like flip the sign of this. Why do math peeps keep doing my discrete unit dirty, saying irrelevant and bad stuff? It's my boy. I don't know about that. Amo.
Yeah, see, I want to just transpose and then make the whole thing 0.
Alright, so let's do it this way. Okay.
And then
Quite right,
do
Jeff.
right here.
Jeff, you gain another year.
This is where I start questioning, what do I do? Because I
What do we
don't know
do?
what else to do.
Yeah, well, okay. So I'm tempted to try to combine the fractions, which means they need to have the same denominator.
So utilize the butterfly method?
Yeah.
So you
Jeff's stealing a year
numerator and a big
from
denominator.
Mathematic Fanatic. So wait, I'm gonna multiply this by like 2x plus 1. 2x plus 1. 2x plus 1, right? Because now I have 2x plus 1, 2x minus 1, right? And then this one's gonna get multiplied by x plus 3, x plus 3. Right?
Okay, x plus 3.
A year of your life, Fanatic, dude. Yeah, you owe a year of your life now to Jeff.
Alright.
Okay, so now, any tips on being better at trig identities? Practice is pretty useful. I think as long as you, are you talking about like all like the double angle, like the sum ones? There's like so many other ones. They get like really confusing.
And then x plus 1
Minus x
x
plus 3. And this is all over
That guard the whole big thing there.
fucking garbage.
2x plus 1, x plus 3, and 2x minus 1.
Yeah.
And then
Hog
you have to
says
put the
you
same
should have
thing in
cross multiplied in the beginning, then group similar terms, and then see. I don't think we can. Well,
I don't think you could do that at all.
I don't think we can. We're debating what happens when you start. I think when you start cross multiplying, you have to start switching the sign of things. This is safe. We know this is safe.
Yes. But so since they have the common denominator, you don't have to put the same thing twice, right?
So yeah, you can change sign without crossing a 0. Yeah, exactly.
So yes, what do you know about? You see if anything can cancel out?
I see. Mathematic Fanatic brings up a good point, though. Yeah, we're just looking for critical points at the end of the day. We're just looking for, like, does this shit equal 0? And then we're going to test. And as long as you test it in your original equation, you're okay.
It was just completely crazy over here.
Yeah. Yeah, you can just find the zeros and check.
So yes.
What's up? This
Don't you just
First time on
cancel
YouTube.
out the stuff?
Well, I want to simplify this, right? So I gotta cross multiply. Or I gotta distribute, right?
What?
I gotta distribute this.
What do you mean?
Not cross
Who
multiply.
can't be serious?
2x squared plus 2x plus x plus 1 minus x squared minus 3x, right?
Oh wow. All over that.
All over.
How do you do trio?
What's up, Machka? What's up, Holmes?
Oh wait. You keep that denominator?
Yeah, you gotta keep the denominator. Because what we're gonna have to do on our number line, we have to check where this is equal to 0 and also where it's discontinuous. So where it divides by 0.
Okay,
so when we do this, yeah, let's do this. So 2x squared minus x squared, that's just x squared, right? Then 2x minus 3x is minus x. Sorry. Actually, wait. 2x plus x minus 3x is 0. So it's just x squared plus 1.
Plus 1. Okay.
Yeah. And then that's over this hot garbage. Greater than equal to 0. But here's the cool thing here. This will never equal 0.
No.
Do you see it? There's no way for x squared plus 1 equals 0.
On YouTube.
Yeah.
That's one thing I saw on YouTube. The one thing that is like you just can't answer, really.
I mean, it could be imaginary, I guess, but yeah. So your critical points, so critical values, sorry, I think is what you call it. Critical values are where the numerator or the denominator equals 0. And so that only occurs at at 3 different. So there's no way for this to be 0. So you just have negative 1/2, positive 1/2, and negative 3. Never say never.
That is actually
You don't get to
craziness.
ask those questions. Okay, so let's mark our number line, right? So we have negative 3, negative 1/2, positive 1/2. So let's go check some shit, right?
There you go.
What do you want to check? Let's just check 0. I like 0, right?
Zero's better.
So if we plug 0 here, we get 1 divided by, so we get a positive over a positive times a positive times a negative. Positive, negative is negative, and then a positive divided by a negative is negative. Right, so that's not greater than.
Disqualified.
So this one doesn't work. Yeah.
Test positive 1/2 to infinity and beyond. That's
Okay, so let's just test like 1. Let's just test x equals 1, right?
So then that means the
positive, and then this is positive. This is positive. They're all positive, right?
So
Positive
that
divided by is greater than 0. This one works.
So then okay, use -2 for between -3 and negative.
Dude, let's use -1. Let's use -1. Negative 1's nicer. Right?
All right then.
Okay, so that's positive. This would then be negative. Right? Negative 2x plus 1. This would still be positive. Negative 2x minus 1. This would also be negative. Right?
That means the whole picture is positive.
Yes. So this is also works, right?
Yes. So, and then that means that the -3 to infinity and to negative infinity and beyond is not going.
So it's like let's try like -5 then, right? So that's positive. That's negative.
Negative. That's another negative.
This is negative.
And then that's another negative. Triple negative.
Triple negatives. Wow. Well, negative is positive times negative is negative. Positive or negative is negative. So this doesn't work. Okay.
And if
so
you
then
write that thing in interval notation, then that
what
should mean square brackets. Square bracket.
Yeah.
-3 to -1/2, and then square union x. Union's next. 1/2 or 0.5, whichever one you want to use.
Wait, Jeff's like, oh no.
No.
Square bracket.
Did we mess up somewhere?
Square bracket. No.
Oh, it's not defined at -1/2. Sorry. Yeah, sorry. It can't be defined at -1/2 or -3 because that's infinity.
Wait. What?
Night, Bella. Thanks for dropping by.
Wait,
Right.
wait.
Yeah. No. It doesn't work because if you plug in -3 into this, you get divided by 0, which is infinity. So it's undefined there. So it's interesting. No, you are correct that usually you would need to use the closed brackets because you have a greater than or equal to sign. But the difference here is that
But then you
because
have to
it's
remember the move.
yeah, it's undefined there. So
All right.
okay.
Well,
So I think that's it, right?
If this is coming on my quiz and test, I think I'm gonna sign up the class.
Nice.
The-
If you're infinophobic,
legit.
You done messed up, Aaron!
someone said we're infinophobic.
Listen, could you just screenshot that thing for me so I can write it down?
Yeah, no, I'm gonna
Because
put
I
it
have
in.
to-
I'm gonna put it in the Discord. Do you know everything goes in the Discord after we do these questions?
Private
So watch.
DMs, please, because I need time to recomprehend everything.
Well, here, I'm gonna tag you. So it's actually really super cool how this works. So anytime we do a question, right, it gets put in here in homework help. See how this is your question, Ethan?
Yes.
And then here's the solution. So there's the screenshot for the solution. And then also this link
All right.
right here shows you the recording on YouTube and also at what time spot. So when you click on this after the stream is done, it'll show you exactly where we did this question during the stream. Pretty cool.
Nice.
If I do say so myself.
And this makes just every day.
Yes. And it's here all the time.
But I mean, hey, I have to say, thank you so much for this help.
You're welcome.
Yeah,
Man.
something though, it's like people say I'm ambitious, and I take that as a compliment. But
Yeah.
since I'm in
Oh,
prefects,
yeah.
I'm considering if I should even go into like calculus 1 and so forth, because it's like I kind of struggling right now, to be honest.
It's okay. Struggle makes magic, dude.
It's just-
Pog Champion,
it's
the
just a
Discord.
post-
Check that link down there. That link has a link to our Discord. The actualofficehours.com. I can't post links in TikTok, sorry. What's up, Ethan?
Seriously, it's like when it comes down to the first one that we did, the RZT, the rational zero theorem or rational root theorem,
Mm-hmm.
it wasn't bad. I could do it easily. I mean, I could take the long way out and just plug in each and every factor to find the thing, and
Yeah, but that
would
just
take a while.
sucks, dude.
You're not that guy, pal. Trust me.
You don't wanna
You're
do
not
that.
that guy.
You don't want to do that, dude.
But okay, so see, that's no problem. But number 4 is where it just gets completely confusing, because what the fuck? But I have to
Yeah.
I have to combine multiple techniques just to answer the question, and then yet you have to remember the math rules where you can't divide by 0, otherwise it's undefined, and then you
Uh-huh.
have all this other garbanzo where you have to like utilize the butterfly method, combine factors.
Fanatic says
Is it
just
not
plug
already
in
a
every
whole-
real number.
Ow.
Says Fanatic says just plug in every real number one at a time.
I hate this. But do you think I should continue with maths like up in the higher levels?
Yeah, dude. Yeah, sky's the limit, dude. Keep going.
I mean, I have to say, like, I'm thinking about going into, well, we have a subject called Math 115, which is college algebra. I'm thinking to sign up for that, even though I'm not required to take it. I wouldn't mind taking, because I want to be prepared for any other colleges that I go out in the real world.
Yeah. Algebra's great.
Do you think I should learn that, because they teach stuff like secant and cosecant, cotangent?
Yeah.
Oh,
Pre-calc stuff, trig stuff. Yeah, that's useful.
Alright then. Well, I might as well sign out.
Okay.
I'm
Yeah, get some
tired.
rest, dude.
I'll be going.
I'm tired too, honestly.
I hope you enjoy your day.
Yeah, you too.
We'll see if I can join tomorrow, but I have a job as well, so.
Congrats on having a job.
1.5 years, soon 2 years.
Wow.
I'll see you later.
Peace, Ethan.
Wait, one thing. Wait, did you, since we've been talking so much, did you put my Bachwine in yet?
I did not. That also gets put on the Discord, on the thread. You'll see it.
Yeah, I almost forgot.
You'll see it. Don't worry. You won't forget. Cool.
You got it? You got
Yep.
it in?
It's there. 3333. Angel
What?
numbers.
Where's it?
College algebra is a bit of a misnomer. Yeah, college algebra is, they call it college algebra. It sounds like it would be harder, but then it's not. College algebra is like easier than high school algebra, actually. It's kind of funny. All right, peace, Ethan. Learn algebra instead. Calc is hard. Yeah. Algebra's great. I think like pre-calc is a course that people don't usually like because it's kind of a random grab bag of topics. And you're just like, what's going on here? Okay. Let's see. This one was proposed by V Sigma. Says, let f be a function that's differentiable in 0. So, I mean, I guess it means you can take the derivative. Sorry, excuse me. Derivative everywhere. Yeah. Find f such that. I think this is, first of all, like, V Sigma, dude. What is? How do you draw your f's here, dude? These are weird looking f's. It's a very cool f, right? Yeah, I guess it is cool. So I think what they're saying is that 3f of 2x is equal to 2f of x plus f of 4x, such that this holds true for all x. X are all real values. Hint, try to construct a function that depends on f of f of x. I feel like I want to do something with the derivative. X equals 0 is an obvious start. Okay. Oh, okay. So if you plug in x equals 0, what? So you have 3 f of 0 is equal to 2 f of 0 plus f of 0. Well, that makes sense, right? Yeah, self-equality, yeah. What if we took the derivative? You want to take derivatives, maybe? I think that could be cool, right? Yeah, let's try let's try taking a derivative. So this is a chain rule, right? So this would be 3 f prime of 2x times the derivative of what's inside, which is like times 2. Derv, not diff. Differential, derivative. So then this would be 2 f prime of x. You only lose 1 month. Okay. Plus, this is gonna be 4 f prime of 4x, right? Does that really help me out though? I don't really feel like it does. Weird. Six f prime 2x equals 2. That's 4 f prime. No, you still get self-equality, right? You still get 6 f prime of 0 equals 6 f prime of 0. Oh, that's not helping us out, is it? Good luck and have fun. GLHF. Are we having fun yet? Would the next derivative help? Okay. You want to take another derivative. So that's 12 f double prime of 2x is equal to 2 f double prime of x plus 16 f double prime of x, f double prime of 4x. I guess that does help though, right? Because now that's 18, right? Oh, sorry. Yeah. Okay, so 12 f double prime of 0 would then equal to 18 f double prime of 0. Cool, so that, yes. So in order for this statement to be true, must be equal to 0. All right, second derivative at 0 has to be equal to 0. Does that force... I don't know if that forces f double prime of x equals 0. I mean, you sort of want to keep going and show that the power series at 0 is 0. But it's not enough to show the functions equal to 0, yeah. I do, Zach. You want to learn some RLC circuits? Yeah, hop in. I got 29 minutes. Good, let's get out of this mess. Says, let's get out. Well, Faizan proposed it. It's a cool question. But, alright. Maybe we'll save this one for, like, later. Or was this... I think this is V Sigma, actually, that proposed this one. There's Zach. Let's get Zach up here.
Yo.
What's going on, Zach?
Not much. How are you?
I'm good. It's Monday, right? Is that what it is?
It is Monday.
It was a very boring Super Bowl.
Monday. I don't know. Are you a Seahawks fan?
My sister lives in Seattle, so I think I kind of had to root for Seattle, but it was an awful game to watch.
My voice at night is odd. Yeah. I'm sorry I couldn't make it even for you. Sorry, Dasan.
Okay, cool.
I'll be done.
Let's teach RLC circuits. Yeah, resistor C circuits.
Yeah, like I know very little. I know Ohm's law, and that's like the extent of my knowledge. So
that's a good thing to know.
I know that's relevant. But like I don't have a lot, and I've got out my notebook here, so I'm going to be taking notes along with you because I want to like just figure this out and be like, how the heck does this work?
Sure. Okay, cool. All right, so we have resistors, which I'll just show like kind of like what they look like in a circuit, right? This is a resistor. And this behaves such that when there is this, with Ohm's law, whenever there's voltage across a resistor, the voltage drop is equal to the current across the resistor times the resistance of the resistor. So here we can just say that V is equal to IR, right?
V equals IR, yep. That's right.
Good. Okay, cool. Capacitors look like this. And we kind of think of them as batteries. They're like temporary batteries.
They like store charge, yes?
Good. Yes, they store charge. And the equation they follow is that Q is equal to VC. Where this is charge.
So this one I want to parse.
Yes.
So you have a charge, you have a voltage, and you have a capacitance. Correct. Tell me about that a little bit more. Tell me about the linear relationship. What are you like? I always find it fascinating that linear relationships are often assumed. Like, why is this a good assumption? Or like proportional relationships. Like in this case, what physically is going on that this is a good assumption? If that makes any sense.
So I think it comes down to just like what the definition of capacitance is. Capacitance is defined as like Q over V. And this is dependent on the material. It's also dependent on like the geometry of things. But in general, a capacitor will collect opposite charges on two different sides, right? And because you have charge... Because you have charge. But why is it Q over V? They just define capacitance as Q over V. It's a number, is what it is.
Let me ask a different question then. Like, I mean, my question is sort of similar to Dasan. What are the units here? Maybe that will help me.
Sure.
What are the units of these things?
Okay. So there's resistance is in ohms, right? But that doesn't. That's just like and capacitance is technically in farads. but in terms of the units of other things, right? Capacitance is also measured in like coulombs per volt, right? Because voltage is in volts and charge is in coulombs, which everything eventually goes down to like kilogram meters per second squared, right? So if we look
which is your force, right? Like you're
exactly.
doing some newtons, right?
Yeah, so like farads, units. Can you give it to us as a water analogy? Yeah. Yes, so a farad is technically a coulomb squared second squared over kilogram meters squared. But no one ever uses this, right? But eventually, yes,
right.
You can break things down into this. Q is electron. Well, Q can be from electrons, I guess. Yeah, I guess it kind of has to be. It must be derived from Stokes' theorem. There is what's called you can do Gauss's law for a capacitor, which talks about the analogy there is like, let me see if I can just find a picture of it. Gauss's law.
Thank you, by the way. I know I'm going to be really annoying here.
No, I want to get like to the nitty gritty.
I will be. I was gonna say, like, I really do want to understand this, like, not just superficially here. Like, I get Ohm's law is that there's a proportional relationship. I can sort of see it, but I'm not seeing the others. So yeah, there's Gauss's law. That looks like Gauss's law, yes?
Yes.
E.dA and all that.
Yes, E.dA is equal to Q enclosed over epsilon naught. And maybe this is probably the good example. Well, this looks pretty cool.
Okay.
Yes, there you go. Don has it. Yeah, capacitance is, and again, it's dependent on the geometry. It's dependent on the material. But how you can like technically figure out capacitance is using Gauss's law, which says that the electric field times the area is the charge enclosed over epsilon naught. So if you were to make they call it a pillbox, but it's like a rectangle, right?
Okay.
You enclose some charge Q, right? And then the area is just E times A. And so this is what you get for like the electric field. Once you rearrange this tells you what the electric field is between two parallel plates containing charge. It's equal to Q over epsilon naught A. And then electric field and electric potential are related by the distance. So,
so like you have, in the same way you have kinetic and potential energy in mechanics, it's similar here with electronics.
Exactly.
The electric field. But the other thing I want to point out that I think I'm seeing is that you have this E times area, but I think that's assuming that the electric field is moving in the direction of the plate, right?
Correct. Yes.
This would be a vector, right? E dot A. But because we're in one dimension, this is really just E times A. Am I reading that correctly?
Yes.
Is that how we interpret that here?
Yes. A is a vector that points normal to the surface area. And E is also pointing, in this case, normal to the surface area. So it's just E times A, because E dot A is the same as E times A in that case.
And for the record, Dasan, I am equally unconvinced. However, I'm trying to get to the bottom of it by asking different questions. So I'm trying to like see if I can get a better understanding. I share your concerns, but like this is me trying to grill gold here because I'm like I gotta feel like there's something else I'm missing, and I'm wondering if by talking this out it'll help me. Yeah. So forgive me for like I said. I hope I appreciate your patience.
Oh yeah. No, it's I always love these types of questions because it makes me like question like what's like assumptions, what do we just like take as from face values like being truth. in this case, like, again, capacitance is a human construct. We just came up with something that relates the charge and the voltage.
But it's like the ability to store charge. That's how I think of capacitance, right? Like the capacity, I'm thinking of that word capacity. It's using that word intentionally to say, I can hold this much.
Right, at this voltage.
What does that really mean? Right. So if I have this voltage, how much can I hold?
Right.
And
it's like, it's an efficiency.
Do
you see how it's Q over V, right? So in general, when you start...
Is it lowercase q or uppercase q?
They're using lowercase q here. I use uppercase q, but yeah, you can also use lowercase.
Okay.
Whatever.
It's because I know the lowercase q is charge.
Yes, I guess you can use whatever q you want.
But it doesn't matter to me as long as I understand that they're the same. They're measuring the same thing.
Yes.
Because like isn't q the charge of one electron?
That's right? little q. That's E.
Little q is that? That's E. Well, I'm sorry.
No, E. So E is equal to 1.6.
This is me trying to get it all straight.
No, you're right. So
when we say
QE is equal to this, is equal to E. It's kind of like what they say sometimes.
I see.
Yes.
I see. So wait a second.
Q sub E.
Because right, what you just wrote is that Q equals 1. As far as my algebraic brain is saying Q is equal to 1. That's not what you mean.
Q sub E.
But like Q sub E. Thank you.
Q
so because I was going to say is Q like the quantity of charged electrons, right?
Yes. It's the amount of coulombs in one electron. Yeah. Which is like the fundamental charge carrier, you know.
Sure.
In physics, you have forces with carriers for those forces. So the electric field, right, is a force that's carried by electrons. But then they start talking about, like, for instance, like, what's the force carrier for gravity? Is it the graviton?
Mm-hmm.
Right. So there's always like something in nature that is responsible for like a fundamental transfer of that force.
Okay.
The reason why capacitance Q over V is that when you start having more and more charge on a plate, that's going to lead to like higher potentials between the plates.
Right.
Well, eventually it would break down.
This is like
eventually, if there's too much charge across these plates and not enough potential, the charge will just jump. And then it's no longer a capacitor. It's just like it's a fried piece of wire. So this is the maximum amount of charge you can put on it for a set voltage.
So let me restate what I think I just heard in a slightly different way.
Yeah.
Because what I've been told is that if you're touching like power lines that are charged, and it's the potential that kills you. So therefore, if you
drop
current that kills a power line,
technically it's the current that kills you.
But it's the charge that went through your body. If you were touching some live wire and you were grounded, that the ability for the charge to go through your body is what's going to kill you. But because there was potential between the thing that is charged and the ground, that like you're connected to those two things, that's what's going to that causes the death, right? But if you were just hanging from a wire, what you want to do is drop down.
Yes.
Right?
Or you want to be at the same potential.
Right. Be at the same potential, but like that would, so you just don't want to be the carrier of current.
Yeah. You don't want to be in between.
And so what I was going to say is if you have enough capacitance, if you have enough storage, it really wouldn't matter on your wire. It really wouldn't matter if you were grounded or not. You'd be fried anyway. That's what that's what you're telling me is if capacitance was high enough that you overcame the critical mass, if you will, of charge, then you'd be fried no matter what happens. That dropping to ground without having things transfer would be impossible. Or what am I saying? I making sense? Like there's a
I'm
point
thinking
at which enough charge is in the wire that it will fry you no matter what happens. If the capacity of the wire, the capacitance of the wire, or the capacitance of your container is high enough that it'll fry you no matter what, if you're grounded or not.
So yeah, the frying thing's interesting. Okay, yeah, because I'm trying to. I think the
I'm trying
words
to put this in a real context here. I'm not. This is how imprecise I am, and I'm telling you, I don't know E&M very well.
Yeah, that's okay.
I know a little bit. I know enough, but I have like the Dunning-Kruger effect, where I know enough to get be
into trouble,
but like get myself in trouble, right? Like
yes.
I know something, but I'm like I don't know enough to be like smart enough like you to be like, okay, you can set me straight.
Mm-hmm. I see. So if there's wire, so wires. Okay, saying like the capacitance of a wire doesn't really make sense.
It doesn't make any sense.
Unless you're talking about like
as I said it, but I'm like
unless you're saying like
the internal capacitance of the wire, because wires are they are coaxial usually, and so if a wire, for instance, has two different sections. So for instance, this is usually what wire is. You have a positive and a negative part of the wire. Then there is capacitance between the two different polarities of this single wire.
Right? Baby Gold explains. So that's the only case that there's like capacitance of a wire. So if we're talking about some wire is at a very high potential, okay? Let's say like this is like V is equal to like very, very high potential.
Oh, would mine change? I'm sorry.
Yeah. No, Zach's change. No, Zach's won't change.
Talk during all that. Yeah. Like
no, it's just mine. No, it's a filter on my mic. Pen's trying to see if he can get your voice to change as well. I could make that an effect.
That would
Zach.
be funny actually if we did.
Zach.
Yeah, Baby Zach. I did do it on my channel sometime. I should do a Baby Zach explains.
Baby Zach explains. So by definition, if wire is at a high potential and the ground is at ground zero potential, yes, then there is a change in voltage. Okay, there's a differential between it. Depending on the charge, then. Right? If you have free charge just like hanging out here, and then you have, I guess, negative charge here, this would create a big capacitor for sure. But having high capacitance means that it's not gonna arc. You're not overloading it. You can blow capacitors because you end up trying to put too much charge on or you put too high of a voltage across the plates, and then they will jump.
So this is like what you see where you see in movies where like you see the thing blow up and
yes,
like, there's too much going into it. That's right.
Yeah, and they create like really big fires. I mean, the crazy ones are the oil-filled capacitors, these massive things. Right. And these are designed to carry these, for instance, yeah. These carry extremely high amounts of charge and voltage. Because the oil helps it to not break down.
Okay.
It's like a buffer in between it. Yeah.
So far my picture of what a capacitor is correct. I'm glad I'm like you're showing me all this. I'm like, okay, I have it all right. I'm not teaching. Like I'm not like when I point these out to my kids, I do know what I'm talking about. Like that's so you're comforting me a little bit.
There you go.
Okay, cool. So the potential drop that happens at delta V is not related to capacitance. Just to clarify, the capacitance is inherent is like a literal
description
storage
of the system
mechanism.
It's a description of the system. Capacitance just describes tons of things can act like capacitors just because there's a difference in potential and there's charge on either side. Those things technically have quote unquote capacitance. But in the case of dealing with circuits and whatnot, right? We this is totally just a man-made equation or man-made measuring tool to just relate charge to voltage. So like for a set voltage, how much charge can I hold? And so things with higher capacitances can hold a lot of charge for low voltages. Yeah.
And voltage here is going to be a measure of like do I say it's a measure of power? Like
no,
that's the one.
No, because power is voltage times like, current. Yeah.
That's no. I was gonna say I failed on that one, but I know they're related somehow. And Dawn says I should question this, so I'm going to.
Yes. The one I like to it's the Ohm law graphic. Is this it? Yeah, this is the one people always like.
I know what Ohm's law. I know the statement of Ohm's law, and I can say V equals IR and all that. But that's like saying, I know how to say sine is opposite over hypotenuse. Like that's great, but like, what does that even mean when you say opposite over hypotenuse is equal across all triangles? Like, I that's about the level to which I can say it. So this picture here.
So voltage is like the push, right? They also use the example here with like a I know Jeff said earlier, like let's start talking about water and like rivers. Voltage is kind of like I like to say it's like the quality of the electricity that you're sending, and then amps is like the flow. So it's like how fast that electricity is moving, and then ohms, which is the resistance, is what is opposing that flow of electrons. And so with higher resistances, there's more restrictions.
And hence in the picture here, you've got this guy with a rope tying together the two ends, trying to say, okay, I'm going to constrain what's allowed to go through.
Exactly.
Right.
Yeah, and these come from units as well. I mean, like, so current, and this is what we'll need. You there, have you seen the anime girl graphic, Don? There's an anime girl one that's even funnier.
Oh no.
I won't pull it up for Zach, but yeah, go find the anime girl overall. That's a hilarious one on Reddit. I still want to do ASMR academics silently misunderstanding research with people. Yeah, Kugels furiously. So current, for instance, is equal to coulombs per second. So this is why it's the rate at which electrons are flowing, or like are moving down a wire. That's why it's a rate. Yeah.
Mm-hmm.
The V equals IR, that just refers to what the voltage drop is across a resistor. And
you said that's coulombs per second? Is that what?
Yeah. So
the rate, the current here?
Yes. So current, yeah, this is current. This is coulombs per second. Resistance, I guess, is then, what are the units for that? It's got to be something, because then voltage is volts. Oh, you saw it, Don? Yeah, okay. Well, let me see volts, units, because voltage is also referred to as like EMF, like electromotive force. Where's all the units for things? Yeah. I guess it kind of looks, yeah, it's over amps. These are such wacky units. No one uses these. Yeah. We make these simplifications just because it's nicer to deal with, but okay, that's it. Yes, it's Newton meters over coulombs. That's what I remember. Okay, yeah. So then voltage. You want to know the integral form of all this stuff? So this is Newton meters per coulomb. Okay. I see. So then what is resistance then in terms of Newton meters? Resistance units, Newton meters or something. Resistance is 1 over S? What is big S is something else then? Let's see if I find it. Webers
Yeah, I
per
haven't seen
Coulomb.
capital S before.
Yeah, I don't know what the
Oh my
capital S
gosh.
one is. Yeah, there's some weird ones in here. Joules seconds per Coulomb. It's even whacker.
my
I don't like
gosh.
that. Okay, don't worry about the units for resistance. Okay. Anyways,
Nice. Thank
so
you.
all right, I think we did a little bit of a dive on like what a capacitor is. Again, yes, this equation.
Okay, we did that. Yeah, we're
equals
okay.
V-
We're okay. Yeah.
This is just
for
man-made.
now, I'm okay.
Okay.
We just make it up because we make up because so the points don't matter and all that stuff. Yeah,
Yeah,
it's fine.
Yeah. No, I like it.
Whose line is it anyway?
It's good to question things. We should definitely question things. Yes, resistance is also weird because it depends on the geometry of the material, right? Some people think that like thicker wire has like higher resistance because it's thicker, but it actually has less resistance because resistance is inversely proportional to surface area, but directly proportional with length. That's kind of the thing we learn about. Yeah. And that kind of also works with the whole like the guy restricting the thing, right? If the wire has a better surface profile, like a cross section, then there are more places for the electrons and the current to pass without bumping into each other. Okay. The last thing we need to learn about though is the inductor. That's the L in RLC.
That's the weird one I've heard. That's
Yes.
like the worst of all.
Yes. Well, so it's actually kind of cool. So inductors and capacitors are kind of like inversely proportional, or they have like opposite relationships to each other. So capacitors resist changes to, I want to say, voltage, whereas inductors resist changes to current. Yeah, I think that's what happens. Yeah. So the reason why an inductor is usually written as this, and we're going to say that like V is equal to L di dt, where this is what's defined as the inductance, which is, again, similar to capacitance. It refers to the geometry in the material and like the properties of the inductor. And then this is the change in current over the change in time. So it's like how fast the current is changing.
Well, that makes sense. I mean, like I can make sense of DIDT. L is this mystery number we don't know.
It's just given.
It's the thing. It's based off of geometry, as you say.
Yes.
So
yeah.
Like the okay.
The reason why. And let's talk about like why this voltage, and technically, sorry, the voltage is equal to like negative L didt. And the reason for this is this goes down to Lenz's law. So whenever you have, let's say, for instance, a coil of wire, okay? And if you have current flowing in it, okay, right? That current creates a magnetic field, right? This you have to learn from, this is like the right-hand rule stuff, but let me make sure we see. Let's see.
Well, right-hand rule, I'm familiar with that.
Are you from
the direction of which?
Are you coil of current? Yes, yeah, there is that. Yeah, this is B is equal to mu naught L and inductance. I want to show like where this comes from though, and I don't want like a coil of current. Wait, I want like a single loop maybe. Well, single coil of current.
Is L the number of loops here?
No. In that case, for this equation here,
the lowercase L.
Yes,
like
this is
the lowercase L.
This is well, no. N is the number of loops. I is the current.
N is the number of loops.
I is the current.
I. Sorry,
Yes.
It looks like an L.
N is sometimes, I think, like loops per unit length, though, is what it depends on. But, okay. If you have electric current running through, let's see here, running through a single coil, like a loop of wire. A coil is just a bunch of loops all next to each other. That creates magnetic field, which points, in this case, in this direction. This also is kind of like by right-hand rule. Okay. Now, if that current changes, then the magnetic field will change. Okay? Like, the magnetic field that's being created by this loop of wire will change. And what we learn from in Lenz's law is that any change to the magnetic flux in a system will then create a back voltage that tries to fight that change in current, or fights that change in magnetic field, which came from a change in current. So hence the negative. Hence the negative. Yes. So when let's say the current goes down, okay? Let's say the current is dropping, okay? Then your new magnetic field would be less, right? So in order to oppose this, I need to then create some sort of current that would return it back to what its usual state used to be. And that creates current, let me think, creates current in the same direction, which then creates a back voltage, I think is how that works. Yeah. Wait, there's a connection to differential geometry from this? Oh, I don't know about that. What is that disinfluence? Yeah, so that's why there's a negative, is that any change in current then creates like a back voltage, like an opposite voltage across the device to oppose that change in current, because it's changing the magnetic field being produced by the coil.
All right.
Yeah. Okay. Yeah, there's probably like an even nicer explanation for this for Lenz's law. Let me see. Lenz's law diagram. This is happy face.
I know it's time for you to go, so I don't want to. We can continue this tomorrow.
Yes.
Time, but
yes. Yeah. Let's. Yeah. Sorry, I do have to go. I didn't realize the timer. But Lenz's law is cool. That's where this comes from for inductors. Oh, there's something in Levi-Civita, so as you move the vector field, the other vectors change proportionally. Oh, okay. Yes. An induced current always flows in a direction that it opposes the change which produced it. Yes. Yeah.
Okay.
And that's why you don't get like runaway situations, because otherwise it would be like this positive feedback loop, and then things would just like explode. Like
and then you'd have resonance, and it would explode.
It would just keep going up. Yeah. Okay.
Is this similar to a Newton's third law scenario?
For every force has an equal and opposite force?
Yeah. Is this similar or is this different?
I think it's different. Yeah, that has to do with like more like forces, and that's if you apply a force, another force applies the force back on you, right?
I have more questions, but like let's get you off the air.
Okay,
I don't want to take more.
No, I like this. Is really good.
Your time.
This is really good. Yeah, there you go. Changes magnetic field cause a change in electric field and vice versa, and that's why we have light. Yes. Okay, cool. I do need to end the stream though, so let's close things off. W for UNM. Yes. All right. Thank you everyone for coming to Action Education Office Hours today.
Bing bang.
Appreciate all the fun discussions and stuff. Yeah, Zach, we'll because this, once we get all this like out of the way, then we can set up a differential equation, and then you can start to see like why RLC circuits like oscillate. It's really cool.
I can also understand why certain professors didn't teach this when I was an undergrad.
Yeah.
Because I still have lots of questions. So
good. I'm good. I'm glad. It forces me to like have to dig deep, but underneath like the surface level, like hand wavy shit. I hate hand wavy. So yeah.
Yes.
Okay.
All right, very good. Thank you very much.
You're very welcome. All right. Yes. Our next stream will be tomorrow. That's gonna be at what is that? 6 p.m. Pacific, 7 p.m. Mountain, 8 p.m. Central, 9 p.m. Eastern. Come on by. You can always check out the calendar. Let's go raid somebody on Twitch. Who are we gonna go say hi? Good to see you, Don, as well. Mathematician, I do have to run, but if you want to drop your question in on the queue, anything we didn't answer today will still get put into our Discord and might get answered later. Let's see who we're gonna go. You're very welcome, Disinfants. Who's streaming some stuff? Dun, dun. All right, cool. Moo Hoodles is doing space and astrobiology. Yeah. Oh, she has a Half-Life shirt. I love Half-Life. Okay, cool. All right, go say hi to Moo for me. Raid Zach will do 100 on balls. Enjoy the start of your week. We will see you tomorrow. Peace.
And they're all so damn expensive. It was yeah, not a good time for me to. I should have bought one a while ago. I think I had it on my list and then I kind of spaced it. Oh well. Hey, Actual Education, thanks so much for the raid. How was your stream? How's it going? I hope you had a great one. Alright. Thank you again for raiding in. If y'all aren't following Actual Education, they do a whole bunch of awesome tutoring and educational stuff for like STEM things. They're a 501c3 nonprofit and you should go follow their Stram. Support more STEM stuff on Twitch. And thank you so much for the raid. Raiders, hi, I'm Moo. I do science communication on outer space and astrobiology. We also talk about sharks conservation, programming, a whole bunch of random ADHD things. And